Hello, I'm Drew Fustini. This is my first FOSDEM. I've been watching videos for many years, so this is my first time actually getting here. So I'm excited to be here. Actually, I'm from Chicago, but I moved to Berlin this past year, so I'm in the area now. I'm part of the BeagleBoard.org Foundation. We make small single-board computers, most popularly known as the BeagleBone. Also part of the Open Source Hardware Association. This is a group that we have an open source hardware certification program. And I mentioned Berlin. If you are in the area, in a couple of weeks, we have the Berlin Embedded Linux meetup. So if you're around, would love to have you stop by that. And then on March 13th in New York City, the Open Source Hardware Association, we organize an annual conference called the Open Hardware Summit. So if you're able to, this will be on March 13th in New York City. And since I mentioned open source hardware, just want to give a brief introduction of what that is. So it's hardware whose design is made publicly available so that anyone can study, modify, distribute, make, and sell the hardware, sell the design or hardware based on the design. So for electronics, which is mostly what I do, that'd be the schematic. You'd be sharing the schematics, the board layout, in the editable source file. So if you're using a program like KiCad, you would share your board file and your schematic file, and then also the bill of materials. And one of the best practices, if you want to do this, is to make sure that the bill of materials, you have the components are available in small quantity. So like with BeagleBone, we make sure that all the components are available in quantity of 1 from distributors. And the reason for, I also gave a talk at CCC recently that I go more into depth about like open source hardware, some of the different licensing, and also some of the different open source hardware boards that run Linux. So if you're interested in that, you can check out my 36.3c talk. But going back to the open source hardware, why would you do this? I would say the main reason to do it is you want to enable other people to collaborate on your hardware project. So by sharing your schematics and your board layouts in editable format, you can get people to contribute back changes to your project. And if you make the components available, if you choose components that are available through distribution, people can actually build your project. So I'm very excited right now about RISC V, which is a open instruction set. So what's an instruction set? So probably many of you have heard of x86 or ARM. These are instruction sets, which is essentially the standard for what tasks a processor can do at a low level, the instructions that the processor can execute. Though with both x86 from Intel and AMD and the ARM instruction sets, they're all proprietary. So if we want to make like an open source chip, we need to have an open source instruction set. So RISC V, I think it's about 10 years ago now. It was started by a group at Berkeley that was doing computer architecture research. So RISC V is a free and open instruction set. I believe it's licensed under Creative Commons, the standard is. So anyone can take that instruction set and implement it. There's a couple of great talks if you want to get more in depth on RISC V. One is from David Patterson, who's one of the people that originally started RISC back in the early 80s. And then also Chris Asanovich, who's the professor at Berkeley that was leading the RISC V team. And he does this talk at probably like every 6 months at these RISC V conferences. So it's always kind of changing because there's a lot of development going on. So if you ever want to check out, like deep dive into what the current state of affairs is with RISC V, is they do the State of the Union probably like every 6 months. So one of the things about RISC V was the idea was to make it a modular ISA that you could be extensible. So to make it last for something that's going to be valid a decade from now, 2 decades from now, they wanted it to be something where they're planning for the future. So there's 32-bit, 64-bit, and there's also 128-bit version of the RISC V instruction set. So the idea being that you know, once we have petabytes of memory, we'll still be able to address all that memory. Yeah, so it's going back to the project beginning, I guess, in 2011, all the way up to now, we have a bunch of different companies that are involved now, and the ecosystem is probably the most important thing, the software ecosystem. So it's fine to have an instruction set, but it's not that valuable if you don't have support in compilers and tools and operating systems. So there's support in GCC, LLVM, Linux kernel, FreeRTOS, now Zephyr. So pretty much everything that you need to have a system that you can develop and build and put into production. So this kind of gives you a bit of an insight into the instruction set. So it actually is a very small base. So the base of the ISA is just a 32-bit integer. So that's all the base is for RISC-V. So you can write software for this base ISA, 32-bit integer, and you'll be able to run that on in the future, we have some like 10-core, 128-bit RISC-V processor. It'll still be able to run this base ISA, which is frozen. But then there's lots of extensions. So this is the RISC-V 32-bit integer, and then there's a bunch of extensions as well. So David Patterson gave this talk, and in his pocket there is what is called the green card. So I guess back in the day when people were programming machines with, like, terminals and teletypes and stuff like that, they would have these cards that showed all the instructions for the CPU. So this is the RISC-V equivalent of the green card. So you can see here, this is just the instructions for the base ISA, which is the 32-bit integer. And it's maybe like 20, 30 instructions. And then this is for all the current extensions. So we have 32-bit, 64-bit, 128-bit, and then there's like multiply and divide, different versions of floating point, compressed instructions. So even putting all that together, it's still not that much. It's not overwhelming, and it's architected so that you can just choose the extensions that you need for your use case. So it was started at Berkeley, at a team at Berkeley. They now transitioned it where it's being organized by something called the RISC V Foundation. So the standard lives at riscv.org. They also have been growing a lot. So I think they have over 400 members now, which is companies and universities. You can also become an individual member as well of the foundation. And one of the reasons to join for companies and universities is they can join these working groups where they're setting these new extensions. Like one of the things I think is in the works right now is vector extensions, so in hypervisors, and so these sorts of things that are adding to the base ISA. You can join the foundation and get involved with shaping those. And companies like NVIDIA is using the RISC-V as kind of like a management controller. They replaced their own proprietary ISA in their graphics card. Not the GPU, but something that helps manage the device. And then Western Digital is probably one of the most heavily involved companies, and they're replacing all the controllers in their drives to be based on RISC-V. So in the future, NVIDIA and Western Digital and other companies will be shipping millions of devices every year with RISC-V processors in it. One of the things companies can get when they do this is they don't have to pay licensing fees for proprietary ISAs and proprietary implementations. But more than that, they get the freedom to implement it as they want. Like, I think with ARM, you have to have an architecture license if you want to do substantial changes to the microarchitecture, which I think only a few companies have, like Qualcomm and Apple. Everyone else, like with BeagleBone, we use TI parts, and I think TI just licenses a specific core from ARM. So if you want to make more changes to like the microarchitecture, you oftentimes can't do that. Whereas with RISC-V, you're free to do that. There's also a lot of open source implementations. So Boom and Rocket from Berkeley, and Pulp is out of ETH Zurich, and Swerve, which I think is the Western Digital one. So there's a lot of open source implementations. Also yesterday there was a talk from OpenPython out of Princeton. They also have this kind of one-to-many core design capable of running Linux called OpenPython. So there's a lot of existing projects out there that people can leverage. And there's this event, I guess it used to be called the RISC-V Workshop. I think now it's called the RISC-V Summit, but these things happen like every 6 months. So if you're wondering what's the latest and greatest that's happening with RISC-V, is you can go to riscv.org, and they just put up the proceedings and the videos from the one that they had in December in California. So if you go to the RISC-V YouTube channel, there's tons and tons of talks on there. I think one of the main ways I've been able to kind of find out what's happening in this community is watching a lot of these videos. So one of the other things I find interesting is kind of the global sense of RISC-V. And one point is that the RISC-V Foundation was based in the US. They're now moving to Switzerland. And part of that is to be free of political implications. Nations like India and I think also Pakistan have declared that RISC-V is going to be their national architecture. And I think that lot of countries want to have more control over technology, want to have more sovereign control over processor architecture. So, you know, in this past year, we saw the U.S. The U.S. current presidential administration prevent U.S. companies from doing business with Huawei, and back at the beginning of last year, it was also uncertain if ARM would be able to do business with Huawei. They ended up deciding it was okay because ARM's a UK-based technology, but you know, I'm sure a lot of Chinese companies don't want to be in the position of not being able to license the cores that they need from ARM. So I think there's a lot of motivation for companies in China and other nations to have more control over the processor technology. And I think like the biggest uptake in RISC V Foundation membership has come from China recently. I tried to kind of give an overview of this in a recent issue of Hackspace magazine. It's a short column, but if you're just trying to get a sense of what's going on in RISC V, it's hopefully a good way to, in like a few minutes, get up to speed. So the first time I saw a RISC V chip was the OpenV, which was a microcontroller from a group in Columbia, Columbian University. They call themselves On-Chip. I think the university is UIS. But this was a 32-bit microcontroller, and it was a completely open source implementation. They also did analog, which was kind of unique about their project, is they were interested in the analog peripherals. One of the other organizations that I've been watching for a few years now is Low Risk. So Low Risk is a not-for-profit organization out of the UK. And I like that their mission statement when they started was they wanted to create a system on chip, completely open source, that you could use to build a single board computer. Some of the people that started Low Risk had been involved in Raspberry Pi, so I was really excited, like, ooh, we could get like a fully open source single board computer. Most recently, they've been working with Google on this security project called OpenTitan, but you can try out their SoC and run Linux on it. So there's a version 0.7 of the Low Risk release right now, and you can get a FPGA development board for less than $300, and you can actually run like a little graphical Linux environment on it. So if you follow this tutorial, I just found out about this like 2 days ago from someone here at FOSDEM, so I'm eager to go try this out myself. So that's kind of like their long-term vision, I think, is to have an SoC that's produced in volume that you could use to run Linux on. Alex Bradbury is one of the people involved in Low Risk, and he gave an interesting talk about the ecosystem for operating systems and the tool support around it last year in the summer. So I'm part of the Open Source Hardware Association, and kind of I would say the equivalent to that to some degree is the Free and Open Source Silicon Initiative for chip design. So they're a great organization. They organize several events throughout the year. So they have ORConf, which happens every year here in Europe, which stands for Open RISC Conference, but there's a lot of RISC V content there now as well. They started doing an event in the U.S. called Latch Up. So last year it was in Portland, and this April it's going to be at MIT in the U.S. And last past year they also did a week of open source hardware at ETH Zurich. So they're a great place to find out like what's going on with beyond just RISC V as well, but with open source chip design. And they now run a website called LibreCores, which you might have formerly heard of as OpenCore. So this is kind of the successor to that. The idea is to aggregate together processor design. So, you know, if you need to get a controller for SPI, or you need to find like a USB controller, you could potentially go on LibreCore. So they're trying to set up a way for you to have a place to go to if you want to share your chip design IP, and if you're looking for something, you could potentially go on there and find it. So some of the people that were at Berkeley that created the RISC V ISA originally went on to start a company called Sci5, which some of you might have heard of. I think it was maybe 2 or 3 years ago now. They launched this microcontroller called the FE310. So this is kind of an Arduino form factor board that has the FE310 in it. So this is nice. It's interesting, but I really want to have a system I can run Linux on. So I was really excited here at FOSDEM 2 years ago, I think it was, that Palmer unveiled the Sci5 Unleashed, which is their 64-bit, quad-core 64-bit Linux SoC. So there's a board called the Hi5 Unleashed, which is a pretty exciting board. It's open hardware. It is unfortunately $1,000 because they only made 1,000 of them, I believe. The idea with this was to be something for like early access for developers. So this is one option that a lot of people are using that have access to it for doing like bring up of distros and tools and things like that. So it's probably like the highest performance RISC V board you can get right now, but it is expensive and only available in limited quantities. So Fedora actually has a RISC V port right now, and they've been using the Unleashed board to bring it up, and also QEMU. So there was this talk back in December at the RISC V Summit from one of the people involved, and here is them running a GNOME on the Sci5 Unleashed board, which requires a lot of hardware, which is probably not something you would probably want to set up if you weren't at one of these companies that's bringing up, you know, something like Fedora. But here's a, you know, an image of what it might look like in a few years if you have a RISC V system and you're running a Linux desktop on it. So the Sci5 solution with the Unleashed board and this FPGA board that does the graphics is quite expensive. So the thing that's much more accessible to everyone is QEMU. So you can, with just your computer that you have right now, your x86 computer, you can download QEMU, and the Fedora image, you can run it on your computer, which is the way a lot of the work is being done right now for people that are bringing up RISC V tool chains and distros and things like that. So here's an example of booting the Fedora RISC V. So if you have the Sci5 board, then this is the flow, but not that many people do. So most people are just working with QEMU. So if you want to get started right now and you don't have any hardware, QEMU with Fedora is one way to do it. There is also Debian. So Debian also has a port for RISC V 64-bit as well. So you can either grab Debian or Fedora and go ahead and start running it on your system with QEMU. Now there is a microcontroller or smaller processor from a company called Kendryte. So this is a really cheap processor. It's a dual core 64-bit. It's 400 megahertz with 8 megabytes of SRAM, which is pretty decent for like a microcontroller. And you can get like dev boards from a bunch of places. Seed Studio has one for $13, so like a really inexpensive RISC V development board. Now, can you run Linux on it? So there's a person at Western Digital, Damien, who's been hacking away at it, and there's a couple of Linux kernel hackers that have been working on it with somewhat limited success. So Damien gave a talk back at Linux Plumbers in September about trying to run it. So one of the issues with this Kendryte chip is that technically it has an MMU, but it's not the right type of MMU. So you have to run it with MMU as a memory management unit. So normally on your computer, in most things that are running Linux, you have a memory management unit. And if you don't have that, you have to kind of take a path that's atypical. So you need to have no MMU support in your libraries and Linux and stuff like that. Linux now has that capability in it to run as M mode. So with RISC V, there's machine mode and supervisor mode. So machine mode is just like we're just running with a unified memory view, not with like virtual memory and user space and kernel space. So right now, they're still kind of hacking away on it. But if they're able to get it working, or if you're interested yourself, you can check out. Here's some links. So here's a screenshot of them booting Linux on that SciPede board that's $13. But it only kind of gets to this point, basically logging into BusyBox. And one of the reasons is without an MMU, you need, I think it's FTPIC support, which is an ARM way of dealing with the fact that you don't have virtual memory. So basically, it's work in progress. If they're able to progress it farther, then we can probably start running RISC V on really inexpensive sub $20 boards and playing around with it. It only has 8 megabytes of memory though, so how useful will it be, I'm not sure. But for now, QEMU is probably the way to go. However, coming up in this year is 3 processors that I'm kind of excited about from having watched some of these talks at the RISC V Summit. So Andes has a processor that's coming out that's supposed to be Linux capable. They're saying Q1 of 2020. Microchip, formerly Microsemi, they have kind of what would be the equivalent to the Xilinx Zig. So this is going to be a FPGA with a hard RISC V core, and that's called the PolarFire SoC. And I think they're talking about second half of 2020. And then the one I'm most excited about, which I saw one of my friends tweet about at the RISC V Summit, was NXP is working with this organization called the Open Hardware Group to produce a RISC V IMX style SoC. So if you've heard of like the Freescale IMX6 or IMX8, they're pretty popular for embedded Linux systems. You see them in a lot of different boards. So I think the idea here is something that has the peripherals that you would normally have an IMX system with a RISC V core instead of a ARM core. So this is supposed to be second half of 2020. I think they announced it would be like clocked at 1.5 gigahertz, so pretty high performance. Supposed to have a GPU, so if it's one of those Vivante GPUs that we have the Etnaviv open source drivers for, then I think this would be really exciting. There's no information on pricing yet, but like this might be something that we could actually build like an affordable single board computer with that would run Linux. Yeah, so by the way, in these slides, there's links to all these different articles if you want to check them out. So one of the things I would love to do is get a group of people together that want to help make a cheap Linux capable open source hardware board. I think we kind of have to wait for a chip like this to come out. So if you're interested in, get in touch with me. However, we don't necessarily have to wait for these SoCs because there are also FPGAs, which is what I have here. So this is a FPGA. It's actually a badge with an FPGA on it, and it can actually run Linux on RISC V. However, this is not going to be the same performance as this. So with the FPGAs, we're talking about maybe 50 megahertz, 100 megahertz, maybe 200 megahertz. So not the same performance that we have in a SoC. So one of the reasons I'm very excited about FPGAs now, like I learned them in school a long time ago, and it was all proprietary IDEs and Windows, and I had to run a VM, and I didn't like it. We now have open source tools for working with FPGAs, which is really exciting. So back at Hackaday Super Conference, which this badge is from, a person from Sci5, Megan Walks, gave an interesting talk about overview of RISC V and FPGAs. So this is another thing I recommend checking out. If you aren't familiar with what an FPGA is, it's a field programmable gate array. So it's basically a chip that has a bunch of gates in it. Like for example, this one has 45,000 gates. And we can take those gates and reconfigure them to implement whatever digital logic we want, including a processor core. So like this one has a soft RISC V processor. That's the fabric. That sea of gates has been configured to be a processor. And then the thing for me that has made this more exciting is the fact that we now have free and open source software tools to do the synthesis and the place and route and load it onto the FPGA. So this started a few years ago with a group of people, most notably Claire Wolf, that started building these tools for a lattice FPGA called the ICE40. It's kind of a modest FPGA, but it was the first one that had like a free and open source tool chain for it. And that referred to as generally as Project Ice Storm. And then this is actually an ECP5 FPGA, so it's much more capable. It can do things like HDMI, higher throughput, things like USB 3, I believe, as well. So this was enabled by the work from David Shaw. So one of the things I have to do with both the ICE40 and the ECP5 is document the bit stream. So that work was done in Project Trellis, so we can now use the ECP5 with these free software tools. And hopefully soon, some Xilinx parts as well. So Xilinx is like kind of the market leader in FPGAs, and if we want to have higher performing parts, the sorts of things we probably need if we want to have like a more usable Linux system in a soft core, then the Xilinx parts are going to be probably the best way to do that. So I'm told in the next couple of months you might be able to use one of these Xilinx boards with the free and open source tools. If you can find him, Tim Ansel is here at FOSDEM. He's pushing hard to try and get these tools working with Xilinx, so he always has the latest information. He gave a talk at Hackaday SuperCon back in November, where it's kind of the status of where this is all at. So this board I'm quite excited about. It's called the Orange Crab. It's from a person in Australia, Greg DeVille. It's a completely open source hardware design, and he's managed to put the ECP5 FPGA on there along with 128 megabytes of DDR memory. So it's a nice little small board that's actually can run Linux quite nicely. We were at the Chaos Communication Congress, and someone was like, hey, you should run Linux on it. And then like a few hours later, Greg and Tim hacking together, they brought up Linux on it. So, and I think Linux boots in like 17 seconds on it. So it's actually not too bad. I'm hoping that Greg will do a crowdfunding campaign at some point this year for it, because I think this would be a nice board for people to get started with. There's also a board from a hackerspace in Croatia called the Radiona. This one has SD-RAM though, so it's not quite as capable as the Orange Crab, but this one will be coming out soon from Crowd Supply. I think in the next month or two, you'd be able to go and back this campaign on Crowd Supply. And then David Shaw, who did the work on Project Trellis, which enabled us to use these tool chains with the ECP5, he created this like ultimate board, I think mostly for his own development needs, but this has like a gigabyte of DDR memory, Ethernet, PCI, all these things on there. This is not available. It's something you can buy. You can build one if you want. I think it's probably a couple $1,000 if you want to build one, but if you're looking for like a high-end board for doing using the ECP5 free software toolchain, then this is probably the highest end one. One of the things I thought was interesting was someone posted on Twitter that what does it look like when we configure our FPGA to be a Linux capable core. So we can see here, like this is like the macro view of the place and route utility called NextPNR. And so this is what it looks like when we've configured all the gates to implement a RISC V processor that's capable of running Linux. So this is the badge from the Hackaday Super Conference. It kind of is in a Game Boy style form factor. I think the primary intended thing was for people to program games and little graphics on it and walk around with like your name in flames or like Tetris and things like that. So there was a graphics engine in C that you could write games on. There was tutorials about how to do this. But there was some of us at SuperCon that wanted to run Linux on it. So we were like, oh, that's cool. It can do all these graphics, but let's see if it can boot Linux. So one of the issues with this was it only had 16 megabytes of SRAM. It's not just it's external SRAM over SPI, so it's quad SPI SRAM, which is not really that great for trying to run Linux. So we banged our heads against it for like the first day and didn't have any success. And then it turned out that someone had showed up to SuperCon having already designed a DRAM add-in board. So we were like, oh, I think we really need DRAM if we want to boot Linux. And Jacob was there, and he's like, oh, well, I designed this before I came. And we're like, ooh, okay, that's what we need. So he had a board here with 32 megabytes of SDRAM, and that proved to be enough for us to be able to get Linux running on it. So one of the other things with this badge was the idea was you'd have cartridges. So this is one of the cartridges. There's other ones like for PMOD connectors and different peripherals. So the idea is, you could give someone a cartridge and they plug it into their badge. So this one, you plug it in and you get 32 megabytes of DRAM. But how did we actually get a system on chip into the FPGA that was capable of running Linux? And the way in like a day, pretty much. So The way we did that was with LightX, which is a pretty interesting project that leverages MeGen, which is a Python-based language for doing chip design. So if you've heard of Verilog or VHDL, these are hardware description languages that people use to design hardware that goes into chips or into FPGAs. So instead of using Verilog or VHDL, you actually program in Python. So it's Python code that actually is describing the hardware, describing the logic inside of the chip, and then that can be that produces something that goes into the synthesis tool. So it allows us to basically do chip design in Python, which proved to be, I think, pretty powerful because we were able to pretty quickly iterate on this and bang away and get it working. LightX is kind of a combination of a few things. So there's MeGen, which is the domain-specific language based on Python. And I'll show you a few snippets of MeGen in a bit so you get a flavor for what it looks like. And the other part of LightX is these IP blocks. So there's like a DRAM controller, Ethernet controller, PCI Express controller, SATA. There's a few other ones there. So these are IP that you can go and grab and tie together to build a system on chip for your FPGA. And then the thing specifically that we use is this project called LightX on Linux. So this takes a RISC V CPU called the VexRISC, which is a 32-bit RISC V CPU that's kind of designed to fit well into an FPGA. So they take that and they take some of this these IP, like the light DRAM controller, Ethernet controller, and they put it all together into an SoC that you can load into your FPGA. So this is Linux booting on the VexRISC, RISC V processor inside of that Linux on LightX VexRISC. Yeah, it's hard to say. Linux on LightX VexRISC V SoC, which we still don't have the display working. So yeah, it's like, to me, this was very exciting. I guess some people like graphics on the display, video games and stuff is more exciting, but we were very excited when we got to see Linux boot over the UART. So after we got back from SuperCon, we were hacking away trying to get it work on one person's laptop, and then I got home and I built the board, and then I was like, okay, I want to get it set up, and it took a bit to like figure out, okay, what is all the different stuff that we changed when we were at the conference. Finally did that, so there is now upstream support in Linux on LightX for this Hackaday badge, which only people that are at the conference has the badge, but if you want to have a sense of what it is like to add a new board to Linux on LightX, you can take a look at these pull requests. Also, just to give you a flavor for what the LightX and using MeGen, which is Python, looks like. So this is basically the file that defines the board. So the Hackaday badge, Hadge badge, and then this is basically defining the different pins that we have on the badge and how they map to signals inside of the FPGA. So whereas you might otherwise do this stuff in Verilog or VHDL, here we're doing it in Python. And we have the nice object-orientedness of Python where we can import things and inherent classes and things like that. And then this is also just kind of gives you another sense of what's going on here. So we can, we import things like the LightX clocks and the LightX SDRAM, and then we can basically kind of just tell it the parameters that we have for our thing. Hopefully I have a screenshot in it for it as well. Yeah, so like we had to add our DRAM module because it wasn't already in there. So we're using a 32 megabyte SDRAM module, wasn't already in LightX, so we just extended what was already there and added a new class where we say, okay, here's our timing. So, from the data sheet, had to figure out the banks and the rows, and then basically the timing, and then it kind of uses all the existing infrastructure inside of like DRAM. So kind of made it a minimal amount of effort to have to bring up a new DRAM chip. And then this is how we add the board into the build system. So thing here is it's pretty basic. If you look at some of the other ones, they have like many different things that is in the base SoC. So our SoC right now only does serial. Right now I'm trying to get it to add in Flash as well, but so it's a pretty basic LightX on Linux SoC. So we just have serial there, and then here is how we actually load the gateware, which is produced out of our when we do the synthesis. So we just use DFU util, which allows us to load the gateware over USB into the badge. So if you take a look at the Linux on LiteX, you can see what some of the other boards look like. Some of them have a lot more capabilities than this one. And then it was running really slow. It would take like 300 seconds to boot, which is annoying. So this was like a great like GitHub moment or open source development moment where I was like, oh, it's going really slow. And I opened up a issue on the GitHub repo. And then like that same day, Enjoy Digital, Florent, who's the person behind LiteX, goes by Enjoy Digital, and he posted an improvement, and it was going 10 times faster. So I thought that was a pretty good open up a GitHub issue, and all of a sudden it boots in 27 seconds instead of 300 seconds. Also, when I was doing this, I discovered this cool thing called ASCII Cinema, which maybe some of you have used before, but it allows you to record your terminal, which was really useful. So like I wanted to show what was happening when the badge was booting up, so I would run ASCII terminal and record it, and then I could post the link in the GitHub issue, and you could see what was happening. And also, you know, sometimes this doesn't boot when I want to show people stuff because the batteries are dead, so I can always just link people to the ASCII Cinema video. And specifically what he did was interesting. So, and kind of shows you the power of, I think, the MeGen and the object-oriented nature of using Python is one of the optimizations was it was having to go to memory too often because it's just an 8-bit wide memory. So we were having all these expensive memory accesses, and it was slowing things down. So he just made the L2 cache 128-bit, and that speeded it up tremendously. And that might not be like a good optimization for everyone, so it's something that you can play around with and optimize it for your use case. And I played around with this number a few times, putting up to 256 to shave off like a couple more seconds. So to me, it was quite powerful. I can just go in there and change these values and go and load it up and see how long it takes and see if that improved it or not. So that's pretty much it. I can hopefully show you what it looks like in the terminal. So this is, we're hooked over a UART here, and what LiteX does right now is it just runs BusyBox, which if anyone's interested, I think would be interesting to do something more like maybe Debian, Bootstrap or something like that. So it's an area of active development. The other thing too is there's drivers for the Linux kernel like UART and the other peripherals that we have in there. So if you're interested in those sorts of things, if you check out LiteX on Linux, there's a lot of opportunities for people to get involved. So let's log into our system here. So we have Linux running on a RISC V processor and an FPGA using all open source tools, which is pretty fun, I think. So if anyone has any questions, I'd be happy to take them. Yeah. So I'll do this first and then that one. Yeah.
It's absolutely fantastic, thank you. I mean, I too have been waiting since I was at uni to be able to play with this stuff.
Mm-hmm.
I started out with the Black Ice MX Phognologies board,
Yeah.
and I got Zephyr going on top of Saxon, so I'm doing that. And this is
I need to have a slide for that. Yeah. So
it's cool.
yeah.
So it's, you know, and again, totally open down to the gates. So I want to be able to put together securable IoT solutions that are just completely open in this way. Yeah. So the next step is to try to follow, you know, what you're doing here, putting Linux onto these boards.
Yeah.
Which is very exciting, and I've taken down some of the examples of boards to get going with. And in commercial terms, if we're trying to manufacture boards, you know, obviously we can go out and get ASICs. It's really exciting to see that NXP are coming out with the RISC V.
Yeah.
We do a lot of work with that. Talking to my colleague who does the hardware side of things, he's a bit sniffy about all this, you know, because he says, well, FPGAs, they're expensive, you know, how do we make this stuff cheap, how do we make it viable? I really want to see completely custom cores with standard soft cores in them, and then some custom magic to do acceleration, sort of build our own open cores in that way. I've heard that there's Libra Silicon, which is a project to do kind of small scale ASIC manufacturing.
Yeah.
And I'm wondering if you know anything about the economics of how this is going to be possible to drive down cost, like open silicon cores that we can put together.
Yeah, so the question was about open silicon and the idea of pushing this down and getting things manufactured for cheaper. So I learned some more about that yesterday. I think there was a talk, or actually I ran into the person that does a thing called Chips for Makers, where he's trying to produce his own SoC, and he's trying to push down the cost by like grouping things together. So there's the Chips for Makers. I also saw some of the Libre Silicon stuff. So there's a group actually called Libre Silicon, and they're trying to have like an open source fab technique. So I think they're working in a fab in Hong Kong, trying to like bring down the cost. So there's the Libre Silicon people, and they're also trying to create like these cell libraries. I think the downside to that is it's a pretty old technology process. The one thing I have heard of that maybe will help, at least in terms of not having to pay for software tools, is yesterday in the Open Piton talk in the CAD tools room, they were talking about having chip EDA tools that are open source now. So there's a project called Open Roads out of, I think, UC San Diego. And they're creating like an open source tool flow for doing chip design. So at least maybe that'll eliminate some of the cost of having to pay for these expensive proprietary tools. Though I think most of that is still going through TSMC. The Libre Silicon people are the ones that I know of that are trying to like do their own fab technology, but it is like older processes. So yeah. And the other thing too, just I should mention, is so I was talking a lot about LiteX on Linux. There's another project called Saxon SoC, S-A-X-O-N SoC. So that's another option for running RISC V, Linux on RISC V and FPGAs as well. Yeah.
So what can you tell us about the Open Source Hardware Summit badge?
I have the PCB somewhere. So this is sadly not Linux. We're using a Nordic microcontroller, but it's going to be a wristwatch style form factor badge. So we were inspired by the badge from camp this year at Chaos Communications Camp called the Cardio. So the idea is a wristwatch form factor badge running CircuitPython. Yes, not RISC V, but hopefully people have fun with it. Yeah.
No, I just wanted to add that if you're finding the microcontroller, there's a Vulkan Nanoboard for $4.90. It sounds expensive, but it comes with a screen.
For the Kendride or?
No,
Oh.
it's from Gigadevice. It's a microcontroller.
Okay. Yes. Yeah. Yeah. So yeah. Yes. Yes, so if people are interested in RISC V microcontrollers, there's a company called Gigadevices that has a really inexpensive RISC V microcontroller. So I think it's like kilobytes of memory, so you're not going to run like Linux on it, but you could run a real-time operating system on it, and they're quite cheap. And I think, do they also have they match the STM peripherals, or? Okay, so they also have the STM32 peripherals, so basically the things you're used to on STM32, but with a RISC V core as well from Gigadevices.
Cheaper without the LCD.
Just want to point out, right now for my job, I play around with the ECP5 a bit. So like the eval board, you get one for 80 euros, like the ECP5 eval board. And also, like an interesting alternative for DRAM could be like HyperRAM. It's just DRAM with interfaces with 13 I/O pins. So it's kind of like optional SPI or something.
So the HyperRAM would be at least better than the Quad SPI SRAM?
Yeah, your DRAM or your DDR memory that takes up like 60, 70 IOs.
Yeah,
so
yeah.
HyperRAM is quite easy to implement, and it goes like up to 330 megabits bandwidth.
Okay.
You lose some for protocol, for reading and writing, because it's not the same lines they do IO.
So how would HyperRAM compare to DDR memory?
It's in between SDRAM
Okay.
and DDR.
Okay.
It's,
Cool. Yeah. And what was the board that was $80? That
it's
you?
a CP5 eval board.
Okay, from
It's
Lattice.
on the Lattice
Okay.
page, yeah. But
Yes.
it's got an Arduino interface, PMOD connectors. I also
Okay.
found HyperRAM already PMOD modules that you can buy from some manufacturers. So that might be an
Yeah.
option to put something together for.
Yeah,
the
yeah.
RISC V platform.
So maybe with this Lattice board from Lattice with the HyperRAM, we could maybe get Linux on LiteX working with it or something like that.
If you don't get one of those badges, and it
Yeah,
would
yeah.
make you poor.
Yes, yeah. Cool. All right. Cool. All right. Thank you.